watch this one. Okay, so we're going to go over the quiz, section 7.3 and 7.4. Let's draw this first problem out. I want everybody paying attention, okay? Everybody should be watching, even if you did well, which are very, very few people. But even if you did okay, I still want you to pay attention, because there might be a couple things that make a little more sense as I go over it right here. L, N, N, Q, and P. Alright, so there's the letters. I'm not even going to put the numbers in just yet. Let's do this. And I helped you guys out a little bit more, not much, but a little bit more than I helped the third period class. Okay, the third period class is what I told them. I said, make sure, when I gave them the quiz, I said, make sure you read the instructions very carefully. Look at the problem, read what it says to do, and do everything that it says to do. Josh, do you have a paper out? Do you have your quiz out? Okay, get it out. This is what we're going over. You're not doing anything else. This is what we're doing. All right? Because I will start yelling and giving my big lecture if that continues. All right? That's a big reason why I gave a big lecture to the other class, is because too many people are doing other classwork, heads on the desk, not paying attention, not taking notes, and all that. All right? You're starting to get me warmed up a little bit, and you don't want to do that to me right now. Okay? So I'm trying to be nice to you, and so I could just say, just forget about it and just fail the test, okay? That's your problem, okay? But I don't want to do that. I don't want you to fail. I want you to do well. I want you to succeed. That's why I'm going through this, okay? It's really the only reason I'm going through this. So anyway, here we go. I told them to make sure you read the instructions. Now with you guys, I even said a little extra. I even said, look at the top of number 1. What does it say? It says identify the similar triangles. And I told you before you take the quiz, I said you need to write what triangles are similar. I told you flat out that you need to do that. And I still had 2 or 3 that didn't even write what the similar triangles were. I don't understand that when I told you specifically to do it. All right? I won't call any names, but you gotta follow instructions. That's what life's about, okay? Following instructions. It really is. If you can learn to follow instructions, your life will be just smooth sailing for the most part. Okay, anyway, here we go. Identify the similar triangles. And they told you this and this were parallel. All right, so you got to figure out which triangles are similar. Well, let's do this in another color. So let's identify the similar triangles. So triangle, and you could call, we got 2 triangles here, obviously, right? You got this big triangle, you got this smaller triangle. So let's look at the big triangle. You can call that anything you want using those 3 letters. Using L, N, and M, you can call it anything you want. I think I call it LMN, so we'll just call it that. But you could have called it LNM, you could have called it MLN, you could have called it NLM, right? You could have called it all kinds of different things. But I decided to call it this. It doesn't have to be, on your paper, it doesn't have to be LMN. It could be any combination of those 3 letters. But over here, this triangle has to match up with the big triangle. The little one has to match up with the big one. So how do you know which letters go with what? Well, let's start marking some angles equal to each other. That helps us out a little bit. I think the most obvious thing would be these 2 right here. Wouldn't you agree? They're vertical angles. We went over this just the other day, I think. They're vertical angles. So they're equal to each other. So we know those 2 match up. Look, I got parallel lines. Why in the world would they tell you that they've got parallel lines? Because you also have a transversal right here. So look, this angle right here is equal to this angle right here because of alternate interior angles. Now, you didn't have to know the reason. You didn't have to write down the reason. You just had to know that those 2 angles were equal. And, of course, these 2 angles would be equal as well. For a couple reasons. Alternate interior angles is one, and third angle theorem for another one, right? If 2 angles equal 2 angles, then the third are equal. All right, so I've got all my angles marked. So let's take a look. If I call this LMN, look where it went. It went from 2 angles, or 2 arcs, to 3 arcs, to 1 arc. Everybody see that? So this has to go in the same order. If this goes 2, 3, 1, then what does this do? It goes 2 arcs, to 3 arcs, to 1 arc. So what am I going to call this then? What matches up with the L? The P, right? What matches up with the M? That's got 3 arcs, and that's got 3 arcs, so that's a Q. And what matches up with the N? Well, they're both the same, so that's N. So that's That's 1/3 of your answer. There's actually 3 different parts to this answer. You had to do this. That's your first part. I'll put a 1 right there. Okay, that's the first thing that you had to answer. Now, the second thing you had to find was, it says find each measure. And then after that, it said it LM right next to it. So you had to find the length of LM. And then number 3, you had to find the length of QP. So you had to find 3 things. You already found the first thing just by writing which triangles are similar. Now you have to solve for LM, which is this length right here, and QP, which is this length right here. Now let me put some numbers in because I haven't put the numbers in yet. It'd be kind of hard to find those measurements if you didn't know any of this stuff. And then this is 12, and this is x minus 1. Not really drawing a scale, is no, I guess it could be. Yeah, 18 and 12. I'm sorry, I was thinking that was an 8. All right, so here we go. We got to find LM. So what do? They're similar triangles, and so we have to set up a proportion, right? Compare one side to another. All right, so I don't know. Let's just take that 18. What am I going to compare? Let's do this in a different color here. Right there. All right, let's compare 18 to something. Well, look, how do I know which one of these sides is corresponding to 18? How do I know which one matches up with 18? Well, I look to see what angle it's opposite. 18 is opposite the angle with 3 arcs, so you come over here and you find the side opposite the angle with 3 arcs here. There's 3 arcs, that's the angle opposite. Everybody see that? So this is opposite 3 arcs, and this is opposite 3 arcs. So the 18 and the 12, they're the ones that go together. They're the ones that I compare. So I compare 18 to 12. Are you with me on that part? Okay, they're the ones that are corresponding. They're the ones that match up. Because if you take a look at these 2 triangles, what did you have to do to this triangle? You basically had to, like, twist it, didn't you? And then flip it to make this one look like it matches up with this one. But don't worry about sitting there and looking at it and saying, okay, I got to twist it and flip it. Then this one goes with this. No, just look which one's it's opposite. Or you could do this. It's also between the angles with 1 and 2 arcs, isn't it? Well, look at this. This is also the side that's between the angles with 1 and 2 arcs, right? There's several different ways you could look at it and say that they match up. All right, so I go 18 to 12. I compared the big one to the small one. Let's look at the other side, this one right here. Which one does that correspond with? Which side over here does this one match up with? What do you think? Yeah, the x minus 1. There's only one more, right, to match it up with, so it's pretty obvious on this one which ones go together. But how do I know for sure? Well, it's opposite this 1 arc angle, and this side right here is opposite the 1 arc angle. Does that make any sense? That's how you know which ones match up with each other. Or you can look at it like this. Look, LM. Which one's LM? It's this one right here. So what does LM match up with over here? It's got to match up with PQ. You see that? The first 2 match up with the first 2. There's PQ, so those 2 match up with each other. So if I went from the big one to the small one, this one I got to go from the big one to the small one. I'm kind of over-explaining a little bit here. I really am. I shouldn't have to go through that much at this point. But I'm doing that because too many people got this stuff wrong. Now you could go right from here and then just do your math. What would you do? You'd cross multiply, wouldn't you? Let me show you a little bit of a trick, okay? It makes it a little bit easier for you. Now, if you wanted, you could cross multiply the way it is right now. But I think this might make your numbers just a little bit easier to work with. Let's take this 18 over 12. Why don't we reduce that? Makes it a little bit easier for us. What's the largest number that divides evenly into both of those? 6 does. 6 goes into this what? 3 times. Into this 2 times. So I'm just going to rewrite it again so it looks nice and clean. If you wanted, you could just compare these 2, couldn't you? That'd be kind of easy, wouldn't it? Now we can cross multiply. You got to be careful, though. When I cross multiply, you have to distribute that 3 through this whole thing right here. A lot of people think they remember to do that, but they don't. So what I'm going to do, might be an extra step to write, but I think it's important to write it like this and put the parentheses there. And that way, you won't forget, hopefully anyway, you won't forget to distribute. So let's go ahead and distribute. That would be 3x minus 3, and this would be 2x plus 6. Everybody see what I did with the distributive property? Multiplied by both of these, took this, multiplied by both of these. Now let's do the math. It's pretty easy. Subtract 2x from both sides, that'll give us an x. Add a 3 to both sides, that'll give us a 9, so x equals 9. So we did all that work to solve for x, but is that my answer? Is it? No, they don't ask you to solve for x. I mean, you have to. I mean, you got to solve for x to be able to get this problem right. That's not your answer, though. You don't circle that. I had a couple people, not too many, but I had a couple people circle x equals 9, and that was their answer. No, it's not what it asks for. It asks to solve for LM and QP. So what do? You just plug it in, right? All right, so we plug in a 9 for this. So 9 plus 3 is 12. Thank you. So 9 plus 3 is 12, and that's LM right there. So LM is 12. And then you put in the 9 for this one right here. QP, which is 9 minus 1, which is 8. And that's what that is. And there's your answer. Those three things right there are your answer. Does that make sense? I was pretty straightforward. It took a little long to explain it, but to actually do the problem, it took less than half the time that it took me to explain it. All right, it's recorded, so if you need to go back and look at it, feel free to do that. All right, but I'm going to move on. Now, this next one looks kind of like what we just finished doing, but with a little bit of a trick. I told my other class, I think this problem was probably the hardest out of all the problems you had to do. Well, maybe number 3 because you had to draw that thing out. But as far as these kind of problems, I think this was probably the most difficult, but I think there's only one little part in here that made it kind of difficult. And after you see it, hopefully you won't think it's that difficult after you see it. We'll see. All right, we'll call this P, T, and Q. We'll call this one S, and we'll call this one R. These two are parallel. And then we'll stop right there. Okay, what is the first thing that we have to do? We had to do what? Identify, tell which ones, okay? If I identify somebody, I'm saying that's the one right there, okay? So if I identify the similar triangles, tell me which triangles are similar to each other, right? And here's the stuff. Now, do you see two triangles here? Yeah, I do. I see this little triangle, this PTS. Everybody see that one right there? And then what's the other triangle? PQR. Yeah, that whole big triangle, PQR. So I got two triangles. It says to identify them. So I tell which triangles are similar. First of all, do we know that they're similar to each other? Well, they both share that angle right there. So angle P is the same for both of them. I got parallel lines again, don't I? And so parallel lines cut by transversal. That means this angle right here is equal to this angle right here. Isn't this the angle of the big triangle? This is the angle of the little triangle? Yep. And then you got this right here. Corresponding angles. And it's the third angle, so third angle theorem. All right, so there's our stuff right there. So let's call this whatever you want to call it. P, what did I say before? PTS? We'll just call it PTS. Now I got to figure out which one of these letters in the big triangle go with these letters right here. Which one in the big triangle goes with angle P, corresponds to angle P? Angle P does, right? Because they share the same exact angle. So I put a P right there. What about angle T? Angle T has two arcs. Which one has two arcs? Q. So Q is going to be one of them. And then what else do we have? S and what else? R. They go together. And so that's how you would write it. PTS or P and PQR. Now, did you have to write a PTS exactly like that? No, you could have written it PST. I think I had somebody write like PQS for one of the triangles. Is that even a triangle? PQS? No. All right? That person was just throwing out letters left and right, not knowing what in the world they were doing. All right? It's not PQS. There's not even a triangle in here. All right? So you compare the little triangle to the big triangle. Everybody okay with that? Have I beaten that to death? I think I have, haven't I? But you're going to see something like that on the test. So make sure that you're ready to identify the triangles that are similar to each other. And you have to put them in the right order. I hated to do it, but some people put PTS and they put PRQ or something like that. It's really close, but they have to match up. The P's have to match up, the T and the Q have to match up, and the S and the R have to match up. Everybody with me on that? All right, and I will be picky on that, I promise. All right, so make sure you put them in the right order. Make sure you know what angles go with what. Okay, enough of that. Let's see what we have to solve for. We have to solve for PS, and we also have to solve for PR. And let me put the numbers in here that they give you because I didn't write any numbers yet. That's 6 and that's 8. This is x plus 3. And this is x minus 1. All right, let's do the scale factor first, the two sides that we know. How about this 6? What side on the big triangle compares to the 6? 6 to 8. Now, if you want to right now, let's go ahead and just simplify it. I think it makes it a little easier if you reduce your fraction. So what? 2 goes into both of these, what? 3 times and what? 4 times, right? Everybody with me on that? Okay, so your scale factor is 3 to 4. Now, here's the part. Remember I said I think this was one of the harder ones that we have to do? This part right here is what confused more people than anything else, I believe. A lot of people did this. If I compare 6 to 8, I compared the little triangle to the big triangle. I compared this whole entire right side of the little triangle to the whole entire right side of the big triangle. But you know what some of you guys did? You compared the x plus 3. Be brave and admit to me if you did it wrong. You went x plus 3 to what? Probably x minus 1. I asked my other class, and more than half of them said that they did that. Anybody in here? Anybody do that? X plus 3 to x minus 1? Yeah. But you can't do that. Why not? Because I'm comparing the entire side of one triangle to the entire side of the other triangle. So if I compare this entire, we'll call it the bottom of the little triangle, I have to compare it to what? The entire bottom of the big triangle. And we have to figure out what the whole entire big triangle is. Well, it's just those two segments added up. So let's add them up. What's x plus x? It's 2x. Let's add up the other numbers. Positive 3 and negative 1. What does that add up to be? Positive 2. Some people put 4 in there. Okay, it's not. It's a positive 3 and a negative 1, okay, which becomes a positive 2. So now, what are we going to compare? We went 3 to 4. I went from the small one to the big one. Now I'm going to go x plus 3, which is the small side, to the whole entire big side. What is it? It's not x minus 1. It's 2x plus 2. That's the part right there that got people in trouble with this problem. Would you agree with me on that for the most part? Yeah. And some people got it right. All right, so you didn't have any trouble with it. But some people didn't. And that would be my guess. I'd say most of the problem was you just didn't compare the right sides together. That's probably the hardest one you're going to have to do on the whole quiz and in the whole test that you're going to take on this chapter. And if it doesn't get any harder than that, I think this test should be okay. But you got to know how to compare these things. Let's cross multiply. I'm not going to write it down this time. Let's just cross multiply in our head here. What's this going to be? 6x plus 6. Cross multiply here, that's going to be 4x plus 12. Let's get x by itself. Subtract 4x from both sides. That's going to give us 2x. Subtract a 6 from both sides. That's going to give us a 6 over here because 12 minus 6 is 6. Divide both sides by 2, so x is 3. But that's not my answer, though, is it? I got to plug it back in to find PS. PS is this little short part right here. Okay, it's x plus 3. So I plug it in for that. So that's 3 plus 3, which is 6. So that PS is 6. But now you have to find PR. What's PR? It's the whole entire side, this whole big side right here. So I'm going to take that 3 and plug it in right there. So it's 2 times 3 plus 2. That's 6 plus 2, which is 8. That's PR. That's my answer right there. So the hardest part was just making sure you went x plus 3 to 2x plus 2. Okay, I think that's the hardest part of that. Would you agree with me? That's probably the part that tricked you up more than anything. I'd say for the most part. I mean, somebody might have made a little mistake somewhere else, but I'd say for the most part, that's the thing. So you got to make sure that you compare them correctly. All right, enough of that. Again, I got that recorded, so hopefully you go back on it and you look at it, slow it down, right? Pause it every once in a while. Go back. Has anybody ever done that? You actually paused a problem, you didn't quite get it, you went back and listened to it maybe 2 or 3 times again. Has anybody ever done that one time this whole entire year? You did that? You did that? Okay. All right, good. That's what you're supposed to do. Okay, that's what you're supposed to do. That's why I put them on YouTube. All right, if you haven't done that yet, I think you've been missing out on learning, okay, on the right way to learn. All right, let's look at this problem right here. It says a lighthouse. I think we did a problem almost identical to this. It wasn't a lighthouse. It was like a tree in Bob or Joe or John. Was it Dave? That's who it was. It was Dave, right? Okay, but it's the same exact setup. Exactly the same setup, except different names, different distances, but the setup was exactly the same. This time, here's the ground right here. This is a lighthouse, this little skinny line right here. I'm not going to try to draw some elaborate lighthouse, okay? That little line right there represents the lighthouse. And it says it casts a 128-foot shadow. Does that mean that's how tall the lighthouse is? No, I mean, you've been out there, haven't you? Early in the morning or late in the evening, right? And you see your shadow and it's like way, way taller or longer than what you are tall. Would you agree with that? Yeah, so it all depends on the direction that the sun's coming down. So let's talk about the sun. Here's the sun out here. It's hitting the lighthouse. It's casting a shadow along the ground. So the sun must be going in that direction right there. Everybody see that? Yeah. Now, it says there's a lamppost, right? And it casts a shadow. Now, in this problem, it doesn't say it casts a shadow and it ends in the same spot. But we did that the day before we took this quiz. All right, so you kind of have to make a little bit of an assumption about this. But we did that in class. So let's say here's a lamppost. It's right there. So that little skinny thing's a lamppost. Looks just like a lighthouse, doesn't it? All right, so what do they tell you about the lamppost? It's 5'3". Okay, now watch this. We did this the other day. I think it was the day before we took the quiz. It's 5 feet, what? 3 inches. Now, you cannot say 5.3 because point something is a decimal system. Okay, how many numbers in a decimal system? I mean, how many? What's it based on? What's the base? It's 10, isn't it? It's based on 10. But inches is not based on 10, is it? So how many inches in 1 foot? There's 12. So you can't say 5.3. It's not the same thing. Okay, so what is it though? It's 3 inches. How do I figure out what the decimal would be? Over 12. That's right, because I want to find out how much of a foot is 12 inches, okay? So 3 over 12 is the same as 1 over 4. What's 1 over 4 as a decimal? Without pulling out a calculator. I hear the lids coming off the calculators. 1/4 is just 0.25, isn't it? So it's not 5.3. What is it? It's 5.25 feet. All right? That's something that you should be able to do. But we did that. We did one almost just like it the day before we took the quiz. You could make it a fraction. You could call it 5 1/4, and then 5 1/4 would be 21 over 4. You could do that. And in fact, when I did it, I used 21 over 4 because I kind of like to work with fractions better than decimals. Kind of weird like that. Most of you guys probably like decimals better, so I'm going to use the decimal. But John, you're absolutely right. You can use 21 over 4. And as long as you do the math right, that's perfectly fine. All right, so that's the length of, or that's how tall the lamppost is. And it casts an 8-foot shadow. So where is the shadow? Is it along this way? Does your shadow go like that? No, I don't see a shadow ever going through the sky like that. Do you? The shadow's always on the ground, isn't it? So it casts an 8-foot shadow. What did the lighthouse cast? 128, right? So I'm going to make this big old crazy thing. So the whole entire shadow from the lighthouse is 128 feet. This is all in feet now. Even that thing right there, we changed it so it's in feet. And what are we trying to find? We're trying to find out how tall the lighthouse is. We'll just call that X. Okay? And again, I felt fine with giving you this problem because we had done it a day or two before, okay? And I just figured you'd write it down. But anyway, let's do this. What are we going to compare? Let's do the X first. So this is the left side of the big triangle. Let's compare that to the left side of the little triangle. So I'm going to go X over 5.25. Now, if I compared the whole entire left side of the big triangle to the whole entire left side of the little triangle, what am I going to have to do to the bottom? The whole entire bottom. What's the whole entire bottom of the big triangle? 128. And I want to compare that to the whole entire bottom of the little triangle, which is 8. And now I just cross multiply and I solve for x. And that comes out exactly 84 feet. No decimals at all. Now, I was a little bit nice. Did you notice a couple of you? A couple of you actually put 5.3 in there and you got like 84 point whatever feet. I actually gave it to you. Okay, even though you didn't convert that correctly. Because you did everything else right. May not do that on the test though. Alright? I shouldn't say I may not. I promise I won't. Okay, you got to get it right on the test. Everybody okay with that? Alright. The next two were actually the easiest two problems of the whole entire quiz. And I don't think some of you realized how easy it actually was. But let's show you. I'm going to put these evenly apart. Do they look kind of even? Whoops. Alright, let's change this one to red. This kind of slants like this. This slants like that. And they tell you that this and this have a tick mark. So what does that tell you about these two line segments right here? What does that tell you about from here to here and here to here with those little tick marks? Come on. What does it tell you? That they're equal. They're the same. Exactly right. Okay, that they are equal to each other and they're the same. So what do you have to do with that to solve for y? Do you have to set up some kind of crazy ratio? No, you don't. You just set them equal to each other. That's all you had to do. Now, here's the thing about geometry. Nah, it was easy. I mean, you hardly had to know any geometry to be able to do that. Okay, it's the other part. This says, by the way, these three lines are parallel. This has to be true for this to work. So watch this. If these two segments are equal to each other, and they're a transversal of these three parallel lines, what do you think's true about this segment and this segment? They're going to equal each other as well. Does that mean that this segment equals whatever this one is? No. It just means these two are the same because they're in proportion. What's the proportion? If this is equal to this, what's my actual scale factor? It's this. If I compare this to this and they're exactly the same thing. Like if this was 5, this would be 5. If this was A, this would be A, right? It's what? It's 1 to 1, right? So the ratio is 1 to 1. So what's the ratio of these two going to be? It's going to be 1 to 1, right? Which means that they're equal to each other. Does that make sense? All right, so if these two are equal to each other, these two are equal to each other. And they tell you that this is 2x plus 1. And they tell you this is x plus 7. And just for the sake of time, I'm not gonna do this. I'll set it up for you. But it's 2x plus 1 equals x plus 7. So you just set them equal to each other and you solve for x. It's just plain old simple algebra after that. You set these equal to each other as well. And then it's just simple. You just solve for x and solve for y. What'd you get here? You get 6 on this one. X equals 6. And then y equals, I think, if you did the math, you got 13 over 2. Or I know a lot of you guys hate to write it as an improper fraction, but you could write it 6.5 or 6.5. Okay, if you wanted to. Doesn't make any difference. And I'd be fine with that, to tell you the truth. You guys will be taking Algebra 2 next year. There's many, many, many times where it's a lot better just to write your answer as an improper fraction and not as a mixed number. Okay, but either way here, I don't care. We good? The next problem is almost identical to it. Almost. It looks a little different though. This time we have a triangle. On that last problem, we didn't have a triangle. This one we do. Kind of looks like that. Kind of looks like that. And then you got another parallel side in here. About right there. It's pretty close. And they tell you that these are parallel to each other. And let's use this color. This is x plus 3. Now this is 3 over 2x. 3 halves x plus 2. This one is 2y minus 1. And this is 3y minus 5. And I forgot one important thing here. They told you that this and this had a tick mark. So what does that tell you about the y's right here? Yeah, they're equal to each other, okay? We just went through that, didn't we? Okay, except you don't have 3 parallel lines here. You have 2 parallel lines inside a triangle. All right? But the same thing holds true. Scale factor, right? The scale factor is 1 to 1, so the scale factor of this has to be 1 to 1, or they're equal to each other. So again, you just set the x's equal to each other, set the y's equal to each other. I'll let you do the one with the y on your own. Let's do this. I know some of you guys have trouble with fractions, and some of you guys, that's the reason you missed this problem, is just because of that fraction right here. You set them equal to each other, you got the y correct, but you missed the x because the 3 over 2 freaked you out. Well, let's see what we do. That's a 1, isn't it? 1x. What's 3 over 2 as a mixed number? 1.5, right. That's 1.5. So watch. If I take 1x, and I subtract 1x, and I subtract 1x from here, there's a couple ways you could do it, but this is 1.5. What's 1.5 minus 1? It's a half, right. So that's 1/2 x. See that? Or you could have done it this way. You could have said, instead of calling it 1, you could have called it 2 over 2. Isn't that the same as 1? Why would I make it 2 over 2? That's right, because the denominator is 2 right here. Exactly right. And then what's 3 over 2 minus 2 over 2? It's 1 over 2. You get it the same way either way, don't you? All right. So that canceled out. Let's see what we have. We got 3 equals this plus 2. Actually, let's do this. Oops. Oh, my goodness. What happened there? I think I hit the Z button instead of Control Z, and the Z made a... See, made that plus sign, which... Watch this. If I go like this, ooh, it does that. Isn't that crazy? Daggone it. I hit Control 0 and I go back to the top all the time. Let's go back to this. Here we go. Let's try this again. Let's just do this. Let's subtract a 2 from this side, subtract a 2 from this side, so that cancels out. 3 minus 2 is 1. And what's this? 1/2 x equals 1. How do I get rid of that 1/2? It's being multiplied. You could divide it by a half, okay? But when we have fractions, and that would be okay. You wouldn't be wrong dividing by a half. What's a better way to divide? When we divide fractions, instead of dividing by a half, we could multiply by the reciprocal. Isn't dividing by a half the same exact thing as multiplying by 2? Yeah? You did that back when you first learned how to do fractions. Okay, so I'm going to multiply by 2. So what do you do over here? Multiply that by 2. What's x equal to? It's equal to 2. All right? So there's a little bit of a trick with that 3/2. I think that... Did anybody set this up right and they just got all messed up with that 3 over 2? Anybody do that? John, it was you. Anybody else? Yeah, you set it up right and you just didn't solve it for x, right? But that's a nice, easy way to do it. We good with that? All right. Now, you did have a homework over the weekend, right? Yeah. I'll go over it tomorrow. So if you didn't finish it up, try to finish it up. If there was a problem or two like what we just went over, look at it on that review sheet and try it tonight, okay? Don't just turn something in with a bunch of scribbles on it and you don't know what you did. I want you to really, really give some effort and really try to get these problems right, because if you don't do that, you're not helping yourself. These review things that I give you, you're supposed to really put out some effort on this stuff. And if you don't, it's not going to help you. And the whole reason I give you this is not just for busy work, but I give it to you to help you, all right? So what was it? It was like Chapter 7, what, Form 2C or something? Yeah, Test Chapter 7, Form 2C. All right, so I'll go over that tomorrow. And then I think I have another review for you in the middle of the week. We'll go over that again. I don't think I have any more quizzes, though. So we'll probably take the test of Tuesday of next week. I don't like to give them on Mondays, so I'll give it on Tuesday. Everybody with me? All right. It's the same stuff that we've been doing for the last couple weeks, 3 weeks. All right, so it might be a little old because you've had it before, but apparently, according to those quiz grades, you didn't really know it. So I want you to know it by the end of this week. That's my goal, and that should be your goal as well. Okay? That's enough.